right, so let's consider tossing 2 coins. So we're going to toss 2 coins. What is the sample space? What's the outcome of all possible events? So what we're talking about is, what does the coin land on? So when you toss 2 coins, you have the choice of landing on heads or tails. So we're going to make a list of like first coin and second coin. So we could have heads and heads, or heads and tails, or tails and heads, or tails and tails. So this is what would be the sample space. And sometimes we call that S. So that would be S, okay? Sometimes you'll see S written like this with one of those little squigglies, sort of a deal. This is another way. I said tails and tails and didn't write tails and tails. That's another way that we could write the sample space. So what is the probability of this event, event A, getting exactly 1 head? So they want to know the probability of exactly 1 head. Now remember, from our formal definition of a probability, it's the number of outcomes, or the number of ways A can happen out of the number of possibilities total. So we look at this scenario and we say, all right, how many different ways can we get exactly 1 head? How many outcomes have only 1 head in them? And we should notice that there's 2 outcomes that have exactly 1 head out of 4 total. So the probability of this event is 1/2. And you could write it 1/2, or 0.5, or 50%. We tend to do decimals and fractions a little bit more than percentages, but it is still legit to call it a percent. All right, moving on. The first 3 rules of working probability is make a picture, make a picture, make a picture. And this is not the first time the book has gone through this mantra of make a picture. It's really important a lot of times to have a visual, just like this. This was a visual to help us see what's going on. One of the more common pictures we'll be making with probability is a Venn diagram. So we'll be working a little bit with Venn diagrams in this unit. All right, let's go through some formal rules and different things that deal with probability. There are 2 requirements for probability. A probability is a number always between 0 and 1. Always. You can never have a negative probability. That does not make any sense. You cannot have a probability bigger than 1. That does not make any sense. You can actually have 0. If the probability is 0, then that means it will not happen, guaranteed. And if the probability is 1, then that means it will happen, guaranteed, or 100%. So written more simply, probability of an event has to be between, this is how we write between numbers, 0 and 1. And the other requirement is the probability of the set of all possible outcomes of a trial must be 1. All possible outcomes has to have a total probability of 1. If you don't quite have a probability of 1, then you're probably missing an outcome or missing some potential that could have happened. Okay, moving on. All right, we have something called the complement. Okay, and this isn't like, oh, you look pretty today. That word is spelled differently. That is C-O-M-P-L-I-M-E-N-T. This is complement with an E. This is a mathematical word. This is kind of like in geometry when you have complementary angles, but this is in probability. It's similar, though, in concept. The set of outcomes that are not in event A is called the complement of A, denoted A with a little c above it. Okay? So here's a Venn diagram. Okay? It's a little hard to see in your video, but you can see it better on your notes packet. And here's all of A. Okay? And then out here in this space where the circle is not is A complement. So here's our trial, and these are the events of A occurring, and these are the events of A not occurring out here in this space. The probability of an event occurring is 1 minus the probability it doesn't occur. Or in other words, the probability of A can be found by doing 1 minus the probability of A not occurring. So for example, if we arrive at a stoplight at the corner of our neighborhood or something like that, and we know the probability that that light will be green when we get to it is, say, 30%, just made that up, then the probability that the light will not be green is 70%. That's that 1 minus. 1 minus 0.3 is 0.7, or 100 minus 30% is 70%. Now, not being green actually includes red or yellow, but I didn't distinguish. I just said green or not green. All right, next. And the next couple of little rules are really important. We have the addition rule and then the multiplication rule. All right, and so moving into the addition rule, first thing we need to talk about is something called disjoint. Events that have no outcomes in common and thus cannot occur together are called disjoint events or mutually exclusive. These two words, mutually exclusive and disjoint, are synonyms. They mean the same thing. So if event A and B have no events in common, we call that disjoint or mutually exclusive. So the circles don't overlap. You'll notice a little further down the page, you've got A and B that do overlap. These would not be disjoint. For two disjoint events, A and B, the probability that one or the other, and that or is a really important word, okay? It means something in probability. A or B occurring, it's simply just the sum of the probabilities of the two individual events. Now this is a new symbol for you guys. This is called the union symbol. It means or. You do need to learn that symbol and know what it means. So when you see this, you say the probability of A or B. And this rule is telling me that we can find that simply by just adding the two individual probabilities together. However, you are only allowed to do that if A and B are disjoint. So before you add probabilities together, make sure you ask yourself, are they disjoint? Can these two events occur at the same time? Like, for example, what is the probability the light is red or yellow? I can just add the red and the yellow together because a light can't be red and yellow at the same time.